good morning. What we're going to do today then is we're looking at the molar gas equations and the different versions of it. Now, our molar gas equation then is we've got PV equals nRT, pressure, volume, number of moles, the molar gas constant and the temperature. The temperature, incidentally, is always in Kelvin, it's always in absolute temperature. If you're given your data in degrees centigrade or Celsius, you have to add 273 to that value to make your equations work. Now, the number of moles and the molar gas constant are always the same in our problems. We call that a constant. Now, it stays the same. The pressure and the volumes change. Now, if I've got different pressures and volumes for one part of my problem to the other part of my problem, I can relate them or equate them through nR, because nR stays the same. If it stays the same, I can lock them together through my equation. Now, that then gives me a useful expression whereby I've got P1 V1 over T1 equal to P2 V2 over T2. But things could get even simpler. Now, if I keep the same pressure, now I put the pressure in red so that you can see that it's staying the same. Clearly, on my expression, if I've got two expressions that are the same on both sides of the equation, I can cancel them out. So I'm just going to put a line through those because we know that they cancel out. This then gives me V1 over T1 is equal to V2 over T2, and we say then that that is at constant pressure. So if you're given a change in volume, or you're asked to calculate the change in volume because of a change in temperature, we're talking about a constant pressure, and you can just use this simplified version of the expression. The same goes for temperature. If I'm keeping the same temperature and I change the volume, well, clearly I'm going to change the pressure. I can put my T's the same, and once again, my T's now cancel out because they are the same. That gives me this lovely expression, P1 V1 equals P2 V2, and then the final version then, where I'm keeping the volume the same, and it's simply the ratio between the P1 and T1. These cancel out, so let's put the line through here, and I've now got these little expressions. So when you're looking at your problem, all you have to do is to decide which of the three variables stays the same, which of them is the constant. That's the one that you cancel out, and I've summarised the three different versions for you just here. Okay?
Brilliant.
All right.